European aviation is entering a new era. Trajectory-based operations, a collaborative and predictable way to manage flights across the network. The objective of Network TBO Solution 2 is to define how airspace user, FMP and NM can rely on a single shared trajectory, collaboratively planned, predictable, and dynamically updated throughout the flight. Building on FF ICE Release 1 for pre-departure processes, FF ICE Release 2 extends TBO into the execution phase. It enables trajectory updates after EOBT and even in flight via B2B services, ensuring all actors share the most accurate 4D trajectory. Trajectory updates can be initiated by flight dispatchers, flight crews, FMPs, or the network manager. A structured, collaborative decision-making process ensures that every update is coordinated and understood across all stakeholders, keeping the entire network aligned. A new concept has been developed for this solution: the negotiation horizon. It is a point in time along the agreed 4D trajectory that defines where the tactical ATC event ends and the strategic trajectory changes resulting from the negotiation process could start. Its calculation considers several parameters which are specific for each ACC: the coordination zone between two ACCs, which consists of the time before entry and time after entry of aircrafts, the trajectory revision allowed parameter, the zone of tactical interest. The negotiation horizon is determined by the aircraft's position. Inside an ACC, it will be the end of its ZOTI. When the ZOTI overlaps with the coordination, the negotiation horizon will be the most critical one, meaning the latest in time. Another new concept developed for this solution is the alteration point, which is the point from which the new proposed trajectory diverts for the filed flight plan's trajectory. It must always be placed after the negotiation horizon. The new trajectory may have a horizontal or vertical change, or maybe both. Now we can see an example of when and how the negotiation horizon and alteration point are used. The flight is taxiing or already airborne, and any of the actors pilot, flight dispatcher, network manager operator, or LTM would like to change its original trajectory. The first step is to get the negotiation horizon and then set a new trajectory from the alteration point. This new trajectory may go to a new ACC. The collaborative decision-making process starts between all the actors implied. Once all actors agree and accept the new proposed trajectory, the flight plan is updated with the new route. In October 2025, the Network TBO Solution 2 project team successfully conducted validation sessions in Bretagne with all operational stakeholders using the following prototypes: Top Sky and Plant. They enable the creation of STAM RPs to optimize traffic. These measures are submitted to the network manager for validation and then implemented by the airline. At network level, the TACT MMI prototype evaluates the impact of each proposed trajectory thanks to its integrated network impact assessment feature. With it, the network manager operator evaluates its impact on the European ATM system. NM is checking capacity constraints, regulations, and traffic complexity. Only trajectories that remain compatible with the network are approved. For flight operations, flight keys and Skyfleet prototypes allowed dispatchers to compute a revised flight plan from an alteration point, being compliant with the negotiation horizon, and submit it directly to NM. In the cockpit, the FAST or Loretta prototype allowed the pilot to access information about the alternative trajectory. Once this had been validated, the dispatcher would send the new flight plan to NM for implementation.
Network TBO Solution 2 brings a new level of collaboration, predictability and efficiency to European aviation, paving the way for the future of trajectory-based operations.